Welcome again and welcome to the part 2 of this video tutorial. In part 1 we've seen how to set up the dapp and do the first configuration. Now we will dive in the smart contract logic that we have to implement to build the chat. Let's go to the code to create our first contract. So I am here in the main folder of the dapp, and I'm going to go into the contracts folder. I can see here that I have two different contracts. Greeting is a contract that is currently deployed and used by the dapp. I'm just going to use this twig greeting, which is just a slightly modified version of the greeting, as a baseline, as a boilerplate for the chat contract. So I'm going to change the name here. I'm gonna change the configuration file here to put it to chat, and I'm gonna go here in the lib.rs to find my my code. We can see here that we have the two methods here, one to set the title and one to read the title. The set title, we actually take the title as a parameter, while the read title will just return the title that is stored on the contract. So we'll just remove all of this. We will not be using them for now. We can just change the name here to our chat contract. That's nice. Let's define chat contract here. So we are basically defining a struct called chat contract, and we implement this struct with some methods. I will not be using this neither. Let's now think about what do we want. So we want a chat. So we want messages and conversations. We can imagine that a conversation will be a list of messages. So we have to first define what is a message to then define what is a conversation. So what is a message? So we will just basically define struct here that we will call message with some fields. So message will be basically a string with a from address. We will need to import this address here from Soroban SDK. Okay. And we will need some macro declaration here. So this, we have to say that this will be a contract type. This will be used under the by Soroban compiler, and we will define some, we will derive some property about the messages here, which will be probably useful for later. So here we are. Now, what is a conversation? Conversation will be a list, basically a list of messages. So we need to import the vec from this Soroban SDK. And so we have defined the basis of our function, conversation and message. Now we need to think about how to store the conversations. Usually what we do when we build Soroban contracts is that we define a data key, a key that we will use to retrieve and write to the storage. So here it would be nice if we could retrieve a conversation between address from and address to. So the key could be a tuple of two addresses, and that will be the key to a mapping of all the addresses. So how can we do this? We will basically create a struct, which will be our conversations key. And this will be a tuple basically with 2 addresses. This tuple will be used in an enum, which will be our global data key to retrieve our storage units. So this data key will take conversations. So this will be the first enum, conversations, and the key to this will be the conversations key here. We will derive some property, basic property here, the clone property, and we will say that it is something that will be used, that needs to be encoded by our contract. Same here, we'll derive some property here, contract type. I think I didn't contract type here. I didn't import it. So here we are. So we now have a way to access our storage. If we want to access our storage, we'll basically retrieve a key like this, a key data key of conversations, and we will retrieve our conversations key, and we'll take 2 address 1 and address 2, and this will be used to read, for example. So we will have to unpack the value, and we will read the environment storage here. And we'll call the get address with the type that we want to get. So we'll call get address with this type, conversation. We want to retrieve a conversation, and we'll give a reference of the key here. And here we do some stuff with the conversation value. And to write inside of the storage, we will basically call our storage instance. So, and we will set at the value of the key the conversation here. This is how we read and how we write. So we can remove this. We will use this later on in the code. Now we could stop here. We have a way to have our message stored somewhere. But if we think a little bit further ahead, we would love to know, like for each addresses, because we want to display all the initiated conversation for each addresses, we would love to have a way to get the conversation that are initiated already for a certain address. So we will do this by creating a new type. So we will call it conversations initiated, and this will be only a vec of address. And this will be used, sorry, I made a typo here, and we will add this to our data key here. Conversation initiated with an address. And this will be helpful for the front end part. You will, if you didn't understand now, you will understand later. This is a little trick that will help us to display the list of all the conversation one user has initiated already. So let's look at our first method, the write message method, which will take as parameter the from address, the to address, and the message string, the string that from is trying to send to. So if you are following well, message string is a string here, but a message is a string and a from address. So we will have to do a little modification here in the code. Okay, so let's see how that unfolds. So first, we don't want anybody to be able to impersonate the from address, impersonate a user. So check that from is authorized. Then we will need to retrieve to check if the conversation is existing. If it's not existing, we will have to add this conversation to the initiated conversation of both from and to. So first, to do this, we have to retrieve the conversation key. Then we have to check if conversation exists. If it does not exist, then we add the addresses of from and to respectively, to and from initiated conversation. We want to record, keep track of every conversation initiated between two users. We will see this in a minute. Then we retrieve the conversation. And little trick here, if conversation does not exist, we are creating a new conversation. So we will just get an empty vec here. You will see in a minute. So now that we have the conversation, we can add the new message to the conversation. And from there, we push the conversation, the updated conversation, back into the storage. Okay, this seems good. Let's do this. So from dot require auth. So if you're unfamiliar with the authentication, I suggest you go on the Soroban resources and you will find explanation about how authorization works on Soroban. Okay, so now we want to retrieve the conversation key in order to check for the existence of the conversation. So how do we do this? We use our little data keys enum here that we defined earlier. So we are retrieving the key for a conversation, and so the conversation key here will be composed of the from address and to address. Here I use clone because I will reuse from and to later on, so it's convenient to use clone. Now I will check the conversation exists. Storage instance. So we are calling this the storage, and we're calling the instance storage. Same here. If you have, there is different types of storage in Soroban. Each type of storage is better to use for like as its own type of application. So you should read a little bit about this to be able to choose which storage to choose from. Here, the best one seems to be instance storage. So I will use this one. So I check if the conversation exists, and if it does not exist, I will register this conversation as initiated on both sides. So I will just use an Apple method that I will call later on. Initiated and from .clone to .clone, and here we go. Okay, I will code this little function a bit later on. So now that we have this, we have updated our conversation initiated, we can retrieve the conversation. So how to do this? We create a new, we interrogate our storage again, instance storage, and we use the get method here with the correct types. Sorry, tech, voila, conversation, and using our key, the reference to our key. And here we'll do a little trick. We'll use the unwrap or vec env. And this will basically give us, if the conversation is not existed, will give us an empty vector instead. Okay, now that we have a conversation, we can add the message to the conversation. So let's build our new message. So this will be a message struct with the message string as message here and the from address here. Perfect. And we push this to our conversation. Now that we have updated our conversation, we can push it back on the storage. And storage instance. And here we'll use the set function. Key and conversation. And this seems, oh, I failed the bracket here. Let's go, and something here that will, so here we set the conversation back for from to to, but the conversation of to from is the same. So we also need to update the conversation from to from. And we should not do this if this is a bit thinking a bit forward, but if we can also send messages to ourselves, we can consider that we can do this. So we should check if from is different from to, as this, so that if from is equal to from, then we don't need to update the other side because it will be the same. So let's key other side equal data key. So we basically doing again all what we've done before, but with inverting here to and from. Okay, perfect. And we are setting this instance dot set key other side and conversation. Okay, I realized that this might be a little small for you here. So let's just make it a little bit bigger here. Okay, this is better. So now I almost forgot this little function here. So let's code this method here. So let's define a function here. So we will call it update conversation initiated. Conversation initiated. We must have forgotten an I here. So taking as parameter the environment, from address to address. What we want this to be doing is update the conversation initiated of from, and then update conversation initiated from of to. So let's do this. Let retrieve the conversation initiated. So this is basically a vectors of addresses. So we integrate our storage, we get the instance storage, and we call the get function here with the correct parameter. So here we want a conversation initiated type here, and we use our, so I didn't do it, I did it in one shot, I didn't do it separately, but here I retrieved the key here, conversation. All right, and we need to take it from the initiated here, and yeah, so here we have our key, and we retrieve from the storage, and if we have nothing, then we unwrap or empty vec like we did before. Perfect. Then we add the to method here. We add the to, so we add the to address to the conversation initiated from, right? And then we set the storage value again with the new updated conversation list. So instance here set here this is why I was doing this in two shot before, because now I have to rewrite this here. So I'll just take it from here. Here, perfect. And I add the conversation initiated from. And this is the first side. Now we want to do the second side. So we are basically taking this again, and we'll change a few things. Once again, we will check if from is different from to avoid having the initiated conversation from twice into the same conversation initiated list, because if I send the message to myself, then if I don't check this and then I add both sides, then the conversation initiated will have 2 times this this new value that we add to the conversation. So here, if I want to be coherent with this, I'll just rename all of that. Maybe this is not the most fastest way to do this. So here we use the to here, and we use the from here, and we use 2 here. Okay, perfect. So now let's just check if everything compiles. So we go to our chat contract and we can either call make or could call make, but let's do it with cargo build. So this will take a little while because it's the first time I run cargo build here. But let's see. Okay, so here we are. We have some little warning that we can correct here. Symbol, short symbol, we don't use them. So let's just remove them here. And that is mainly it. Nice. So this is compiling. Now what remains to do is to be able to access this data, conversation initiated from outside the blockchain. So we'll write basically two helper methods for reading the state of our contract. So we'll define two methods: read conversation, and we will also be doing read conversation initiated. Here. Okay, so let's start with read conversation. So normally this should be quite straightforward here. From address, we want to query a conversation between from and to. Okay, so we retrieve the key as usual, if I may say now. Conversation key from .clone to .clone. Maybe this should have been done otherwise with reference instead of cloning everything, but that's how it's been done here. We don't need to put it mutable this time because we will just return it. Environment, storage, instance, get conversation and our key, and we unwrap or return an empty vec. And conversation. So we could have basically removed this, but that's our read conversation. If we do the same for read conversation initiated, let key, so here it will be conversation initiated. Here the key will be conversation initiated with our from address here, and we will retrieve conversations initiated here by getting the conversation initiated key and otherwise an empty vector. This looks good. We just have to return the correct thing here. Let's check. Oh, we have some errors here. Okay, so from is not in the scope. Of course, I haven't inputted the parameter here. Here we go. Conversation initiated, expected nothing. Yes, of course, I haven't said that I was returning conversation here, nor that I was returning conversation initiated here. Okay, how about that? Some warning. Okay, we are not using the to address here, which is very fair. We don't need the to address here, we just need the from address here. And here we are. This is very cool. So this is our final contract. So I will not discuss too much about testing here, but you should write tests for your own contracts. And to make sure everything is fine before deploying it and seeing that nothing is working on chain and not knowing why. Now that our contract is done, in order to deploy it, we need to build the WASM blob of the contract. So we'll do cargo build with the release stack and the target specified to be WASM 32 unknown. The contract is now built. Now we can see that in the target file we have the WASM 3232 blob here, which will be used for our by our script to deploy the contract. Let's now deploy our contract. To do this, we go with the terminal, we go to the contracts folder, and from there, this contract folder is a little package of its own. So you can run your package manager to install dependencies. Here I already had dependency installed, and then you can run the deploy script with yarn, and this deploy script will take as a first input the network you want to deploy to. This could be FutureNet, or this could be testnet. You could also put FutureNet or mainnet if you have inserted the correct mainnet RPC. So Jan deploy testnet here, and we can list our contract. We can just say contract 1, contract 2 by name. Here we want to deploy the chat one. If we had another contract, we could just deploy with like saying, oh, I want to deploy greeting too. So I'm just going to deploy the chat here. So this is building the scripts and then using the deploy.js script. So he finds the given address for the deployer, and then he deploys the contract. So we can see we have our new contract address here. This is also written in deployment.json here, and this will be used by the front end to retrieve our contract and interact with it. Okay, so now we have our contract ready to roll, and now we have to see what's happening on the front end side. Thank you very much for following along, and now we'll dive in the front end side on the next video.